Okay, this task is on hello world in C. Now, when you run a C code, it's going to first of all go through the preprocessor stage, which is everything that starts with an hash symbol, and then is gonna go through the compilation stage. Then we have the assembly stage, and then finally we have a linking stage whereby it links everything it compiles together. Now, what the preprocessor stage does is that, when you write your code, you first of all say a hash symbol like hash include stdio, hash include stdlib.h. Those are header files, and those header files are called preprocessor. Now, getting a preprocessor from your C code using GCC, you have to use the -e flag. Doing that, I have to create a file called main.c. Okay, I have this now. This line gives me a preprocessor. If I use this -e flag here, I'm going to see that I will get all the text in this stdio.h header file, also known as preprocessor. So let's compile it with the dash uppercase E flag main.c. Now I got all the text. So what -e flag does is that it goes to the preprocessor, it copies everything in that particular header file, and then it pastes it into a single translation unit, where also my text for the main.c, int main, and my return 0 is. Next up is compilation. How do we compile a C code? Compiling a C code, we need the -c flag, and then if I try to compile this code right here, I will say gcc-c main.c. Now the code is being compiled. When we look at it, we see a file with .o, and then if I vim into main.o, I'm going to see the compiler output, which I can't understand. In here we have machine codes. Next up is assembling. How do the C compiler assembles our code, and what flag do we need to use if we want to do the finish the preprocessing stage, do the compilation stage, and then see our assembler output. Now I'm going to use the -x flag, uppercase X, say gcc-s main.c. Now it doesn't output anything for me because it gets stored in a file, and that file is in main.x. If I vim into it, I'm going to see a hexadecimal format, also known as here is assembly code. Now all this that starts with a dot is a section in assembly. We have the file section, which is defined in main.c. We have the text section, we have the global section, we have the type section. Now the type is a function, main function. This NB arrow, it says end branch 64, then it's going to push into RBP register. I said everything that starts with a dot is a section. Then it goes into the section, move ROSP into RBP. I'm not going to explain this now, maybe in a later video. So that is for assembling. Next is write a script that compiles a C file and create an executable named C is fun. Now in order for us to create an executable, we need the -o flag, and then the executable will give it a name after we do the -o flag. How do we apply that in C? gcc main.c -o which is renaming the output. Normally the output will be a.out. If I compile it, I'm going to see a.out, which right here. But if I want to change it from a.out to other names, then I'll use the -o flag. gcc main.c -o c is fun. If I hit enter, then my executable right here is C is fun. If I run the executable by using /C is fun, then I'm going to see my output. Obviously there's no output because I did not print anything to standard output in main.c. Now if I try printing something, vim main.c, let's try to print f. Let's start to print hello world. Let's change the name with -o flag, then run it, and then I get the text hello world right here. So that is we covering the preprocessor stage, the compilation, the assembling, and now knowing how we can change the output to whatever name we want to give it. Now up to number 4, write a C program that prints exactly hello. Programming is like building a mingling puzzle followed by a new line. Use the function put. You are not allowed to use printf. Your program should end with the value 0. I say when we echo shebang, we get 0 as our output. So let's use putS. One main difference between putf and printf is that putf accepts only a string. So let's see a scenario where we use putf. Going into main.c again, then says char pointer name equals, I'm going to copy it, paste it here. Now in order for me to get this this hyphen right here, I'm going to use the backslash so that it creates an escape character for me called hyphen. So if I compile again using gcc, C is fun. Okay, I didn't run it, sorry. And I'm going to print, use putchar, not printf, putS, then name, and then okay, this won't put it in a new line. Okay, it does. So putchar automatically puts it in a new line. PutS, sorry. Programming is like building a multilingual puzzle. Next one is write a C program that prints exactly with proper grammar but followed by a new line. Use the function printf. Now this one is super easy, I won't go into it. Next one is write a C program that prints size of various type of on the computer. Now we can do this using a operator in C called size of. There it is. Just do, sorry, let me change the color. To red, I think. Just do call size of, then put it the operation name here, say size of int for instance. My handwriting is very bad. Once you call size of, then it's going to just print the size of int using the format specifier, which is, I think it will give you an integer, so use $d. I think maybe yes, maybe no. Number 7, write a script that generates the assembly code using the